Hello everyone. Today we will discuss new topic and that is graphs. Okay, hope everyone is fine. Okay, graph. What is graph? So graph is a very powerful method to representing the information. Okay, suppose large of information is given. Suppose a match is going on 1 to 50 over in 1 over 10 run, 2 over 15 run, 3 over 0 run. Like this information is given how to represent in the graph. If we represent in the graph, that the information is very easy to understand. Okay, take an example like this. Suppose this is given here over here runs. Okay, like this, like this. Okay, suppose this is team A, and we can also represent the data of team B. Okay, here over, suppose in 1 over 10 run. Okay, if this graph is given, this is very easy to understand in which over, okay, what run is made by which team. Okay, this is roughly example. Okay, we will see in deep also. So mainly the graph is very powerful method to representing information. That's why we use graphs. So what is the definition of graphs? Here I have written a graph plotted between two variable quantities. Okay, the quantity that is varied at our choice called independent variable. The other quantity which varies as a result of this changes called dependent variable. Okay, generally we plot on x-axis. This is x-axis, everyone knows. If anyone confusion, they may ask. X-axis, this is y-axis. Okay, generally we represent x-axis in independent variable. Okay, I think you are able to see this. This is independent variable, and on y-axis we represent dependent, okay, variable. So like this we represent the graphs. Okay, so in our syllabus, first is distance time graph. In distance time graph there are three situations, or you can say three cases. Let's see the all cases. Don't write anything from here. I will provide the notes of this topic. Okay, so first is distance time graph. Very interesting topic. Let's see. So what is this distance time graph? The distance time graph represent the change in the position of a body with time. Okay, so what I told, the distance time graph represent the change in the position of the body with respect to time, या फिर with time. Okay, three cases. First case is, take first case, case 1. Case 1 is when the body is at rest. When the body is at rest. See here in case 1, here we take time, and time is in second. Here distance, and distance is given in meter. Let's draw one table. Okay, suppose this is time in second. This is more convenient to understand. Suppose at initial time, this is at 5 meter, object is at 5 meter. Okay, suppose in 1 second object is gain. What is the condition? When the body is at rest. In 1 second, again the distance is 5, 2, again 5, 3, again 5, like 4, again 5. So like this, 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. See how to plot the graph. This is independent variable, this is dependent variable. See here, at time 0, object is where? At 5. Means from here this is origin, or you can say that this is reference point. Okay, so where is object? At 5. Again, suppose at time 1 second, object is where? Again at 5 meter. Here at 2 also 5, 3 also 5, 4 also 5. Means like this we have to draw the graph. This graph shows that body is at rest at a distance of 5 meter from the origin. Okay, so you can say that the position of a body does not change with time. This in maximum book this is given. Okay, like this given, but this is also correct. Suppose time, second, and distance in meter. Okay, so this is the condition when the body is at a distance of 5 meter. What is the difference between these two graphs? See, suppose the body is at in the origin, okay, on the origin, like this. So this graph is also correct. So what is the main difference between these? These both graphs shows that the body is at rest. But what is the difference? This graph shows that body is at rest at a distance of 5 meter from the origin, and this graph shows that body is on the origin. Okay, got it? Now come to the next second case. And the second case is when the body is in uniform motion. Case 2, when the body is in uniform motion. Okay, let's draw one table. I am taking the table because this is more convenient to understand the graphs. Time in second and distance in meter. Okay, let any information 0, 0, 1. Okay, 1 second, 20, 2, 3, 4, 5, 2, 3, 4, 5. Any information to get take, but be careful, the body is in the uniform motion. So when a body moves with a uniform speed, okay, it covers equal distances in equal interval of time. Okay, means what? In first interval it travels 20, then 40, 60, 80 and 100. Okay, like this. The table is suppose given. So when the body is in the uniform motion, okay, so you can say that distance traveled by the body is directly proportional to time taken. What is the meaning of directly proportional? From this chapter, this is the directly proportional, inversely proportional, and I will suppose take an example. Suppose x is directly proportional to y. Okay, x is directly proportional to y. Its mean when the value of y increases, then the value of x will also increase. Okay, if the value of y decreases, then the value of x will also decrease. Okay, one other word is coming, that inversely proportional. So what is inversely proportional? X is inversely proportional of y. Okay, this is directly proportional, this is inversely proportional. Okay, so when the value of y will increase, then the value of x will decrease, and if the value of y is decreased, then the value of x will what? Increase. So you can say that here the distance traveled by the body is directly proportional to time taken. Got it? So let's draw this graph again, same way. Here distance and distance in meter, here time and the time in second. 1, 2, 3, 4, 5, 6. Okay, when you plot this graph on the graph paper, then you have to take scale also. Okay, like you everyone knows how to draw the graph. Now here origin, then 20, then 40, then 40, then 60, then 80, then 100. Okay, so at time 0 the body is at origin. Okay, at time 1 second, where is the body? At 20 meter, like this. Here 2, 40, 3, 60, like this, 500. Okay, so the graph will draw like this. Okay, so this is case 2, when the body is in uniform motion. Okay, then the graph will make like this. Okay, now come to the next topic, and the next topic is in case 2. In case 2, one thing is left, how to find speed of the body by the help of this graph. Okay, so let's see. One second. Now, speed from distance time graph. Speed from distance time graph. Okay, same time and second, and here distance in meter. How the graph will be like this, I already told. Okay, I'm not writing the information in 1 second 20 meter, in 2 second 40 meter, like this. Not just I draw the roughly diagram of graph of what? Distance time graph. Okay, so let's start how to find the speed from distance time graph. So consider a small portion AB on this graph. Like this was here. This is A and this is B. Okay. After that, you can from both point A and B draw lines perpendicular to x axis and y axis. Okay, like this. Draw the perpendicular like this. Okay, so what I told, from both points A and B draw lines perpendicular to x and y axis. Okay, suppose this is time t1 and this is time t2. Here you can say distance s1 and here distance s2. Okay, thus in time t2 minus t1, distance travelled by the object, that is what, s2 minus s1. Got it? At time t1, okay, where is the object? At s1. At time t2, where is the object? At distance s2. So what I told, that in time t2 minus t1. Okay, t2 minus t1. t2 minus t1 means, suppose this is the point C. t2 minus t1, that is equal to CA. Okay, distance travelled, how much? Distance travelled, and that is equal to s2 minus s1. Okay, s2 minus s1, s2 minus s1, and s2 minus s1 is equal to bc. Okay, I am repeating again. Consider a small point AB of this graph. From both points A and B draw what? Perpendicular to x axis and y axis. Okay, corresponding to point A, distance travelled by the body in time t1, that is what? s1, and corresponding to point B, distance travelled by the body in time t2 is s2. So in time t2 minus, here t2 minus t1. Okay, here t2 minus t1, and t2 minus t1 is equal to CA, and distance travel, that is s2 minus s1, that is equal to BC. Now what is the formula of speed? Speed is equal to what? Distance traveled upon time taken. Okay, so what is distance travelled? You can write s2 minus s1, or you can direct write bc also, but write s2 minus s1, and what is the time taken? That is t2 minus t1, and that is equal to distance of bc upon ca. Okay, so this is the speed of the body from the distance time graph. Okay, got it? Somewhere in some books that is written v is equal to tan theta also. This is slope. Okay, this is what? Slope. And what is tan theta? Tan theta is also the slope of the line. So I think tan theta is in the class 10th, but here no, that tan theta is equal to perpendicular, this is base, and this is hypotenuse, is equal to perpendicular upon base. Okay, so in some book that is written V is equal to what, tan theta also, or V is equal to S2 minus S1, okay, upon T2 minus T1 is equal to BC upon CA is equal to tan theta. Got it? I hope got it. Now this tan theta is important to understand the next topic in this only. Okay, when the theta is increases, what happened to the speed of the body? Let's see. Suppose a graph is given. Suppose first graph I draw what, like this, here like this. Here what is the slope of this line, means what is the value of theta? So theta is equal to 0 degree. Got it? So theta is equal to 0 degree. So what is the speed? Means V is equal to tan theta is equal to tan 0 degree, and that is equal to 0. Means here the slope is 0, so the speed of the body is what? 0. Okay, now see second diagram. Suppose second diagram is like this. Okay, any name you can give. Suppose this is A line, this is B line. Okay, and this is suppose anything you can take, theta 1 or theta dash theta 1, and this is second one is theta 2. Now here what is theta 2? Theta 2 is greater than theta 1. Theta 2 means slope of the B is greater than slope of the A. It's mean what? The body B moves faster than body A. Means body B moves faster than body A. Means what? If the value of slope, or you can say that if the value of theta is increases, it's mean what? The speed of body increases. Got it? Okay, now come to the third case. And the third case is what? Is the third case is when the body is in non-uniform motion. Means case 3, when the body is in non-uniform motion. Correct? So again take non-uniform motion. Means time in second and distance in meter. Okay, 0, 0, 1, 5, 2. Any information you can take. 2, 20, 3, 45, 4, 80 and 5. Anything non-uniform motion. Okay, so suppose this table is given, okay, and you have to draw the graph of non-uniform motion. So let's draw. Here time in second, here distance in meter. Okay, at 0, suppose 20, 40, 60, 80, 100, 120, 140. Here 1, 2, 3, 4, 5. To at 0, it is 0. At time 1 second, where it is 5. Let 5 is here. At 2, this is at 20. At 3, 45 means here. At 4, 80 here. At 5, 125 near about here. So the graph will like this. Okay, means curve. Okay, so the distance type graph in this case is curved line. Got it? So when the body of the motion is retarded, suppose this is accelerated motion. Okay, you can also say that when the body is in non-uniform motion or accelerated motion. So when the motion of the body is retarded, then the body has negative acceleration. The slope of the distance graph is reversed, means like this. Okay, and I draw like this, means acceleration is here, acceleration is positive, here acceleration is negative, means what? Retarded motion. Okay, and the distance time graph is a straight line when acceleration is 0. Suppose this is straight line and acceleration is 0. Got it? So in distance time graph there are 3 cases. Which one? First one is when the body is at rest, second one is uniform motion, and third one is non-uniform motion. By uniform motion you can find the speed of the, or you can say that by distance time graph you can find the speed of the object. Okay, we already see how to find the speed of the object. Speed of the object is equal to what? S2 minus S1 upon T2 minus T1, and that is equal to tan theta, and tan theta is equal to what? Slope of the line. Got it? So if you have any confusion regarding this lecture, you can ask me. Okay, in next we will see velocity time graph. Okay, thank you.